Thank you everyone for coming, and thank you for taking the opportunity to come and listen to my tech talk or Jakarta EE talk. So without further ado and wasting your time, let's begin. So to introduce myself, my name is Bukake. I currently live in Johannesburg in South Africa. It's about 32 degrees right now, bright and sunny. So some countries it's a bit colder. Well, there's a beauty about living in South Africa. I've got over 18 years of experience. My entire career basically is enterprise Java. So I've started from way back in 2006 doing software development for IBM. So Java EE has been, or J2EE was at the time. So until today, I've been dealing with enterprise Java application, even consulting to this day. Yeah, so on top of that, I'm not a boring techie. So I do run just to keep myself active. I do sometimes blog, and I've started a non-profit to try and teach kids to code called DevOps for Kids. I'm a member of the JCP, and I'm a Jakarta EE ambassador. So you've probably seen me active on social media, particularly X or Twitter, or if you can find me, and also on LinkedIn. So if you want to get hold of me, these two are the most predominant platforms to get me on. So to begin, we would like first to go back to the beginning of large language models. It's basically neural networks that is specially designed to process natural language processing. So basically take natural language like input text in natural English or natural language of your choice, and then produce results that humans can understand. But since neural networks actually deals with numbers, we need to translate our contextual text into a numeric format that AI can understand. So how this is done is through some transformation models. What it does is it takes your natural words and then tokenizes it. And then, so those tokens is basically kind of for the AI to basically understand which tokens are best matched with the next token. So once it's done that, it gets embedded so that it can create a semantic meaning. And then the transformer then takes these embeddings and then to understand the context. And then from there, the reverse happens. So it tokenizes it and then to generate human readable text. So it cannot really think, but it's trying to understand certain words, which one are the best words that actually matches based on the input, the best words to match to generate the response, basically. So there are small language models and large language models, but we're focusing on large language models, which is like they have billions of parameters. So the more parameters they have, the better they are. They can be categorized to do specific tasks. For example, translations. To do text summarization, you don't really need billions of parameters compared to translations. So in that aspect, and then one way to access as developers to run LLMs is either that you can access it through various APIs like OpenAI and Mistral have the REST APIs available. Google has REST or gRPC, or you can run it on an AI platform like using TensorRT LLMs from NVIDIA, or you can actually run it locally. So I run certain models locally, but you need to have a GPU enabled with CUDA architecture. So not all, for example, graphics card can actually support running LLMs. I'm running LM Studio, so basically I download uh, the GGUF for the language models that I want to run, and then I run it through LM Studio, and then Bob's your uncle. So, and the beauty of this thing is because it exposes also API, open API kind of REST model. So you can actually invoke you can create your open API object, run it locally through LM Studio, and then get a response. So everybody's now trying to use the OpenAI kind of format to actually expose the LLMs. So, so as as AI is busy evolving, so it's a lot of companies, a lot of startups are also coming around with a lot of AI agents and a lot of AI features. So we've seen a lot of expansion in voice, video, and image generation, and the more parameters that get exposed over time, the better it becomes. And also, yeah, a lot of corporates have included a lot of AI into the cloud, like we've seen Watson, Amazon with Bedrock, Microsoft with Azure, Alibaba as well with Alibaba Cloud. They also have their own LLM with this Night Queen 2. So we see the expansion of a lot of LLMs growing around in the industry, Twitter with Grok and Facebook with Meta and Llama 3. So the landscape, we don't see, AI will not die any soon, considering there's a lot of investment into AI. Amazon has just pumped 8 billion into Claude, and kind of a similar deal with Microsoft and NVIDIA. And the future of sentiment right now is if AI will not replace your job, but those that do not incorporate AI into the current work will basically fall short and die, because AI now is seen as a tool that advances work much faster than people without using AI. So it's basically an enabler to human capabilities and human thinking in a way, but it's not there to replace humans. Okay, but we Java developers, we don't want to focus about a lot of these economics of AI. So the big concept of AI that we've seen lately are, for generative AI, are AI agents, RAG, fine-tuning, and prompt engineering. So all of us is social media or all over the internet, you will see a lot of posts about improvement, how to write better prompts for your AI to get better results, or how to create chatbots using your favorite LLMs, for example. So to do that, you will need to interface with various LLMs. And then, as you know, AI LLMs are stateless. Basically, once you send the input and come back, it doesn't really understand it unless you make it context aware. So, or you have some kind of chat memory. So basically, you will have to take your previous conversation input and output from the LLMs, feed it into your next prompt, and so that it can better understand what you basically talking about. If you do not do that, it does not remember exactly what you've previously fed it to. And for embeddings, you'll need probably a vector store to actually take your document to feed it into the LLMs and to generate your embeddings, so that you can have so that you can create RAG, for example, and you need various tools to actually do that. So LangChain4j is one such library that allows you to do this. It started as Python, but they also evolved into Java. So they provide an API model, a unified model to interface to all your various LLMs without you as a developer having to worry about how the structure of each LLM's REST API looks like. And then it also provides toolboxes to do common features like prompt engineering, function calling, so you do not have to do translate the function to response from your prompt to actually to call your functions in Java. And it also supports RAG, so basically you can ingest your document and then link it to an embedding store. It will embed all your embedding vectors into your vector store. And then when it's time for retrieval, which is called indexing, and then when it's time for retrieval, it will actually take your prompt, take your vector, and then pump it into your LLM to generate a better response. And then if you want to participate into LangChain4j and contribute, there's a GitHub repo, basically. So LangChain introduced chains, which they decided they're no more going to further develop. So they introduced LI services. So AI services basically is a high-level API, which basically hides your low-level components to interface with your LLMs. Because initially you will have to create if you wanted to do a chat model, you will have to do a builder to create a chat model, pass all your parameters in, and then have it call to your LLMs to generate that. So your AI services basically allows you to create basically an interface or where you can actually call with your contract and then generate and then register it into an AI services, and then internally built in, it will create a proxy for you with all the configuration done for you, so that when you just call the function chat, it will know exactly to create a user message, send it to feed it into your LLM, wait for the response, come back, and then return the message prompted from your response. So, but then if you come from an enterprise development like ourselves, you'll know that we do have such type of interface kind of contracts before, such as a repository and a REST client. We just have to annotate them, and then there's a method get your data that you kind of need. So, for example, your repository will connect it to your persistence store, get your data, and return it back, for example. And so, why don't we do the same? So, and things like your repository and your registered REST client are also CDI managed. So, can't we take the same thing that we have done here? So, take your AI services. Why don't we do the same? Have it CDI managed and have it annotated so that you have a CDI application that you can actually interface with. So the solution we've been working on is SmallRye LLM. SmallRye LLM takes your AI services and generates a declarative client and then which is also CDI integrated. So we have a portable extension, and if you have CDI4, you can use a both compatible extension as well. So it would basically register your AI services into a CDI declarative client, basically, without having you to worry about how to make it CDI compatible. And then we've added additional features for microprofile. So to create your chat model or your embedding model or your embedding store or whatever, you can have it configurable. I'll show you later. We've included fault tolerance, for example, so you can use retry and timeout on your method. So if it takes too long, it will time out, and you can actually have it observable connected to some metrics. We included some observability through telemetry, so you can actually see as you invoke your AI services, what data get passed into your LLMs, and what data you get, and what parameters you get passed through the LLM and the response as well. So, and then all of these can run on any microprofile or Jakarta EE compatible application server. So we have tested this through Open Liberty, Elidon. I think there's example for Quarkus, Elidon, Open Liberty, Wildfly. So microprofile and Jakarta EE compliant will basically run this. So in a way, you'll have your application, which will be your AI service, which will be first through your smaller LLMs, so your CDI extension, which eventually calls long chain AI services, and then long chain basically does all the connectivity and does all the component pluggability for you, calls the LLM service, and then returns it back, and then your application, you just get a response in a way. So CDI support, we have introduced the annotation at register AI service. So basically, your application by default is request scoped. You can change it by providing inside the annotation, the field scope. You can change it to application or whatever scoping that you feel like. By not providing one, it's basically request scoped. And here's an example of an assistant, basically. So this is like an AI agent, which we've registered as a AI service. And we say the chat language model name is a chat model. So basically on your configuration, anything that's as chat model, it would use that to register into the AI service automatically. So your LLM configuration, you'll see it's prefixed with smallride.llm.plugin, and then you see dash chat underscore model, which is basically your chat language model name that we specified here on your register AI service annotation. And then, so you would definitely need a class, which is basically the chat model class that you want to use. So for this instead, we're trying to use Azure OpenAI chat model. And anything that's got config is basically the builder that will create your concrete class that you specified above. So all this thing that's got config dot and the property is basically all the property that's available on the builder. So in this case, it will be Azure OpenAI Chat Model Builder, and then it will automatically pre-populate the fields. If there's no such field, it will just skip it, but it will send you a warning. And then the last one, we say listeners dot So basically, if you want to include chat model listener, you just say listeners, and then for now we support at all. So meaning whatever chat listener you pick up by the bean manager, included it to the listener. So this is useful for us because, as I said earlier, we have metrics and metrics that we want to include as well. So the listeners actually picks it up. And then, so that's for your chat model. For your RAG, so basically, RAG is basically a process to improve your LLM. So it basically, by allowing your algorithm to search other external sources like the web or your database that contains factual information that you want. And then for Lang4j, goes through two process, the indexing and retrieval. So for indexing, it takes your documents and then breaks it into each segment and then creates embeddings and stores it into an embedding store. So you can choose whatever embedding store that you provide. I think there's a I'm actually forgetting the name. PG Vector Store. So that's one popular one. And then for retrieval, it's basically when you ask a specific question that's specific to the context or to the data that you want the LLM to actually query to. So it will basically take your input query, create an embedding, go into the embedding store, take relevant segment based on your embeddings, and then send it to the LLM, and then for the LLM to generate a response, basically. So for that, we also got, it's basically a similar process. So on your config property, you'll have to specify a retriever, basically. So the retriever basically will take your embedding store and your embedding model, and then the config is basically also the context retriever builder, and then you specify your model and your store, which you basically need for it to do the RAG. And then you'll see like lookup.default will basically says give me the default. So if there is more than one, if it picks up more than one embedding store by the bean manager or the CDI instance, it will basically fail because it says, I do not know which one is the default. So basically that's what it is. It says, give me the only instance of that embedding store that I can find, and also the embedding model, and then it will automatically generate the content retriever for you that you can inject. So the way that you would inject it is through an ingester. So you'll see at the bottom, there's an ingest method. So it's basically a CDI event. So it will, the ingester will basically take your embedding model and embedding store with the properties that's already configured on the properties file, and then it will create your ingest, and then you'll see at the top the default embedding model and the embedding store. It's basically producer methods, so it will pick that up to actually try and ingest it. So once your document is loaded with the load docs, it gets ingested and stored into an embedding store for you. So here we've used an in-memory embedding store. essentially. Other features is function calling. So if you want your LLM to basically call your function call, LangChain4j allows for you to annotate your method with that tool. And once that's annotated, if your LLM response comes with a description of the function to call, LangChain4j will automatically call that method that's annotated that tool and then execute that method. So you do not have to worry about function calling specifically for you. And then other thing that we've included is fault tolerance, as I spoken earlier. So this is, for example, telemetry 2, where with our Liberty Call booking service, as it actually captured the attribute that was sent to the chat model and the response that it came. So you will see the parameters that we've sent and the response as well, how many input tokens and output tokens the input tokens that was used by the LLM and the output tokens that we returned, basically. So, and then fault tolerance as well, but that's also included. So now I can show you demo examples. So let me see. Let me share my demo. Share. Now I need my. Let me find. Okay. All right. So the examples are, so I'm using Liberty for now. So excuse me for now. So for example, here's an AI service full screen. Where is this now? So here's an AI service, for example, that we've declared, which has where we specify tools is the booking service. So that's for basically your RAG. So there are various tool methods that we've already declared here, like cancel booking or get booking details, etc. And your AI service has some fault tolerance annotation, but it also has this fallback method is basically for a fallback. And then we have a typical chat question. So if you go through the examples and you go through the reading, there are some possible questions that you ask. So for example, you can say, when you run it, and wait, let me actually share the entire window. Share. So here, for example, you can see this is API. And if you run, for example, one of the questions that we ran, and execute, you'll see it running. And it says, and the responses are cancellation policy, miles or miles. So basically, the application loaded on startup, loaded all of these four documents, basically information that we provided earlier. So we specified on the properties file that this is the folder to load the data in. So here it says reservation policy. So let's see, where's reservation policy? So reservation lost in 7, and so there's cancellation. So it says lost in less than 3 days cannot be cancelled. So it picked that one up. And so it's basically, we asked about the cancellation policy, and it returned us the cancellation policy that we fed it on the following where, so our ingester service. So it took the config, the folder, and here it's basically ingested all the documents that we fed it into. So that's quite useful, and to show that the application is that we are actually observing. There's our service. So Jaeger is basically for your telemetry, and we said, and you see here on your right hand side that there was a service that ran 2 minutes ago, and you can actually see exactly which tags it actually populated. So you know that you can actually observe. It's quite a useful tool to see how many tokens that you put in and how many tokens that you return. As you use your LLM, for example, for bigger purposes like image generation or RAG or video rendering, you can actually monitor your tokens, because obviously there's vault cost and etc. and stuff like that. So that's basically your, what else? And we can actually also demo, for example, let's say we want to cancel to show how RAG actually the two function calling works. So let's say I want to cancel. Oh my God, why is this? Oh well, my browser just died on me. My IDE just froze on me. Let's see if I can find it. Um, okay, so here one, and then let's cancel one quickly. Before let's cancel with, let's say, I mean, let's get all the list of bookings first, because then otherwise one.
We're receiving a few comments that we're noticing the font size is a little too small. Is there any way you can increase the font size?
Okay, where, okay, so this one here, this one here. Okay, so we asked for the list of bookings, and then so we have, it says for my bookings, these are the following three. And then if you want to cancel one, we can actually say, yeah. So we've trying to cancel the first booking from the response. So if we say cancel that, it should basically call, still frozen. That is it. That's beautiful. It should basically call the cancel booking. So, well, this one says it's scheduled from 2024 to 2024 13. Reservation can be canceled. Okay, so there's obviously the policy there that we cannot cancel. So let's find one that's cancelable. James one, James one. All right, let's run it. Let's see. Huh, I don't have cancelable bookings. That's interesting. At least the policy rules works. Oh well, I guess I've expired all my bookings. But essentially, what I'm trying to show is it actually calls this to see if, wait, actually I can actually show this by going through the message logs. So, oh God, I've got thousands of logs. There's matrix logs. Let's see, control F, demo. See, so here, for example, the AI service Langchain actually called my tool method get book spawned. And if I find another one, well, yeah. So function calling is actually possible by it's actually possible through from these reg functions that we've already done. So essentially, if I go back here, I've just demonstrated that it is possible to take your AI services from LangChain, get a CDI compatible, and then LangChain will actually do all its internal magic for you. With the existing micro profile features that we've already implemented, and then Bob's your uncle. So for us, basically, on the chat resource, my IDE is actually frozen. When everything is supposed to go well, it doesn't. So Now I have to go back here. Just to show you again. The chat resource, the call booking resource. So if we, so as you can see, the chat AI service over here is basically an interface. There's no reference implementation whatsoever. So the chat AI service is basically an interface. But because we annotated with the register AI service, it's basically the CDI extension basically registered this as a CDI managed declarative kind with LangChain4j AI services running internally. So, but all these other annotations like system message, for example, that's LangChain4j annotations and at 2. And so you can still use AI services that LangChain4j has, but we accept that we managed it to work the Jakarta EE way and the micro profile way, basically. So, yeah. So, that's about it on my side. Anybody has questions? Wait, hold on. I forgot. Okay, good point from Samantha. Good point about AI not replacing humans. I like to define AI as augmented intelligence. It augments human intelligence. It cannot stand alone. It needs humans to add context to AI technology. And it can also reduce the amount of time to do time-consuming tasks if done by humans to speed up the work. Again, an augmented characteristic. That's actually true. Oh, code is too small. Sorry, I was rushing time. So sorry, yeah. Finally, the code I forgot to show, if you give me time. Everything is available on GitHub. So if I can find it. Everything is available on GitHub through SmallLLM and the examples as well. So you can run it through, let me zoom. You can run it through your container of choice. And yeah, well, I don't see Wildfly here, but we have tested it to run on these application servers, and to include it on your project is basically your form.xml, for example, and so you just include your small portable extension and Bob's your uncle, and it will. And if you want to include telemetry, you include telemetry, and then for our example, I use LangChain Azure OpenAI. As I showed on the configuration file, you can actually I specified the class that I wanted to use Azure OpenAI, and then I specified my own API key and all of that into the property file. But I won't show it here because then it gets leaked and everybody else gets to use my API keys and stuff and interface, and then I did both. So yeah, and any more questions with the at register AI service of application? Where does it get the context from? Is the context scoped to a user session? Oh, okay. Register AI service. Yeah, okay. One question. I can show you. My ID is still dead. So let me get quickly here. No. SPR. So the scope is here on the edge. So we have a scope on a register AI server. So by default, we make a request scope. So you can make it application scope by actually say scope equals application scope.cloud. Then it will set it as an application scope declarative client automatically. So yeah. So if you do not specify anything, it's by default it will be request scoped. So yeah. Thanks, Samantha. Oh, that's from Tobias. Thanks, Tobias. Thank you for your time and listening to my presentation. I'll put the presentation online and feel free to chat to me online if you have any further questions.